My name is Rashawn Thomas. This is my demo for the digital frequency meter. Here is my ID card. Now I'm first asked to explain how pulse counting was used. The signal into the modular counter was on each rising edge or each event of that signal, the counter would increment. So the operation of this system was to basically count the number of pulses for a particular signal for 1 second. So we used the 0.5 Hz signal and signal F and sent that through an AND gate. So whenever the 0.5 Hz signal is high, it should be 1 second. That output of the AND gate went into the modular counter, and each rising edge of that signal, the counter would increment. So that's how we got the frequency. So it would be the number of pulses for 1 second, which is equal to the frequency. Right, to illustrate this, I have a simulation. So clock AND here is the 0.5 Hz signal and signal F. So that would be the output of the AND gate. And this is sent into the modular counter, and we can see on each rising edge, digit 0, which is the least significant digit in the modular counter, is incrementing on each rising edge. So as I said, pulse counting in this system was done using the modular counter, and the frequency was measured by counting the number of pulses for 1 second. For the second part, on board now you can see the upper range. This is a measurement of 10 kilohertz. It's showing 999. The counter starts counting from 0, so every measurement would be 1 less than the expected value. So this is the measurement for the upper range. You can see the scrolling from right to left, the display of hertz, the decimal point. Now if I press this button, this push button here, it scrolls at a rate of 10. If I press this button, it scrolls at a rate of 100 hertz. If I press both of them, I have it that it remains at 1 hertz. So naturally it's scrolling at 1 hertz without any input. To measure the lower range, just have to change signal F. Okay, so this is the lower range measurement of 10 hertz. It is showing 9.0 hertz and the scrolling. This is the select display switch, so you can switch between the upper and lower. That's reset, and these are the push buttons to change the slide rate. Okay, this is the middle range measurement of 1000 hertz. It's showing 999.0 hertz. So I'm going to demonstrate or explain how I did the units for hertz and the decimal point. So we can see here I concatenated the representation for H and Z and enclosed by 2 zeros to make it the 32 bits. Well, in this case it would be 40 bits actually for holding it in, because of the extension, the extra bit needed for the decimal point. So I have 1, 2, 3, 4, which is 0 followed by another 0. That 0 means that the decimal point is off. 1, 0, 1, 0, which is my H, followed by 0, meaning decimal point is off. 0, 0, 1, 0, which is 2, followed by 0, meaning decimal point off, and then another 0 followed by 0. In my time marks, you can see how I dealt with it. So now display LED will be 5 bits, and if the decimal point is off because it's an active low, here it would be 1, the segment would be 1, and if it is on, the segment for that would be 0, and all of that is mapped in my UCF file, so you can see it there. To explain the slide, I have to go into my shift register. So in my shift register, I basically it's shifting from right to left, so the most significant digit is moved to the end and all of the prior digits are pushed up. So hopefully you can see it here in this statement. The most significant digit is moved to the end and all other digits are pushed to the front. And for the slide rate control, I can demonstrate it here in a simple process, a case statement, where if it is 1 1, meaning that there's no input to the push buttons, then, well, first of all I should explain that select shift is my input into the signal into the system, sorry, that would control the rate of the sliding. So if it is 1 1, select shift would be the 1 Hertz. From all of these signals were generated in the frequency divider. If it's 0 1, as you saw, it would be 10 Hertz. If it's 1 0, it would be the 100 Hertz. And when is anything else, like if I hold down both push buttons, I have it that it would remain at 1 Hertz. To have them slide through from left to right, to do the shifting operation from left to right, the least significant digit would have to become the most significant digit and all other digits would be pushed to the right. Okay, here you can see the shifting from left to right. As I said, the least significant digit moved to the front and pushed down all other digits. So now you can see the 999.0 Hertz scrolling from left to right. Same control rate. The 100 Hertz is very fast, so you really can't see anything. But yes, so I explained how I did it, I demonstrated it, so I believe that is the end. As I said, my name is Rashawn Thomas. This is the end of my demo. This is my ID card. Thanks for watching.